So we're going to talk about Edgenuity, Honors Algebra 2, Section 6.4, the Fundamental Theorem of Algebra. It has two objectives. One is to apply the Fundamental Theorem of Algebra to determine the number of roots of a polynomial function. And the second is to use complex conjugate theorem to factor and solve polynomial equations. And we'll do some of the stuff that we already did in a previous section as well. So let's talk about first about what the fundamental theorem of algebra is and how to use it. And it's got a pretty basic thing. So we've got three different terms: roots, solutions, and zeros. Okay, and they really all kind of mean the same thing. They're sort of specific to whether we're talking about function equations or equations set to zero or graphs. That's why we have three different terms. But the fundamental theorem of algebra says that if you want to know the number of roots or the number of zeros or the number of solutions, that all you have to do is look at the degree of the polynomial. So in A here, there's the degree of the polynomial. So this one has three solutions, three roots, or three zeros, okay? If you look at B, you got to find the degree defining term, which is this one, the highest power, and then the power is what tells you how many roots, solutions, whatever. Okay, so this one has two solutions. And then we've got this one. This one is written a little bit differently. And so what we want to do is we want to do a little bit of math with this. X squared plus 6 squared like that means x squared plus 6 times x squared plus 6 again, which means if I take this and distribute it to each of these, I'll have x squared, that is that x squared, times the entire x squared plus 6 plus that plus right there, this 6 times x squared plus 6. This is called distribution. And then I distribute in the more traditional way, and I get x to the 4th plus 6x squared plus 6x squared plus 36. And really all that matters is that there's the degree defining term. So this is going to have 4 solutions, 4 roots, 4 zeros. Okay? Now, the trick is that sometimes roots, zeros, solutions, whatever you want to call them, sometimes they can repeat. Sometimes they can be complex, meaning they involve I. Okay? So that's an important idea here. But that's the real basic idea. Look at the degree of the polynomial. Sometimes you have to do some math, some basic math to figure out what the degree is by putting some stuff together. But look at the degree of the polynomial, and the degree tells you the number of roots, the number of zeros, the number of solutions. Okay? I'll pause a moment for questions. All right, there being no questions, I will move on. So let's talk about how to find all the zeros of some sort of big polynomial. All right, and so I want to find all the zeros of this polynomial. So I'm going to have to do a few things. I got to do a little bit of side work. here. I'm going to get all the possible roots by using what we learned last time with the rational root theorem, meaning I'm going to take all factors of 18 over all factors of 1 and do plus or minus with each one. So factors of 18 are 1 and 18, 2 and 9, 3 and 6, there's no 5, and then we're back to 6. So that's all the factors. Factors of 1 are just 1. So possible zeros are plus or minus 1 over 1, which is 1, plus or minus 18 over 1, which is 18, plus or minus 2 over 1, which is 2, plus or minus 9 over 1, which is 9, plus or minus 3 over 1, which is 3, and plus or minus 6 over 1, which is 6. And then we have to test those. It's easy to test one. It's not so easy to test the other ones, okay? So to test the ones, I just plug them in and see if I get an answer of 0. I could do that with a calculator for the other numbers too. That's possible. I could like set up a table either on a graphing calculator or you can even use a spreadsheet for that. But I'm just going to plug in positive 1 and negative 1 and see what I get first, just in case one of those works. Okay? So if I plug in 1, that'll be, that is to say positive 1. That'll be 1 to the 4th, which is 1, minus 7 times 1, which is 7, plus 13 times 1, which is 13, plus 3 times 1, which is 3, minus 18. So let me change these minuses to plus negative, as I like to do, and we'll see if we come out with 0. So the two negatives, when I put them together, that's 25. The 3 positives, when I put them together, is only 17. So this does not equal 0. So I know it's not going to be positive 1. I'm looking for it to equal 0. If it equals anything else, I don't care. So let's check f of negative 1. That's pretty easy to check also. Negative 1 to the 4th becomes positive 1. Minus or plus negative 7 times negative 1 to the 3rd, which comes out to be negative 1, because negative 1 times negative 1 is positive 1, and then positive 1 times another negative 1 is negative 1. Plus 13 times negative 1 squared, which is positive 1, so 13 times 1 is 13, plus 3 times negative 1 would be negative 3, minus 18 or plus negative 18. So let's simplify that down. That's 1 plus positive 7 plus 13 plus negative 3 plus negative 18. So let's put things together. If I put the negatives together, I get negative 21. And if I put the positives together, I get positive 21. So that's nice. So this is 21 plus negative 21, which is 0. So that's what I was looking for. So x equals negative 1 is a 0. So that's helpful, right? That helps me a lot. And then what I want to do is I want to take this x equals negative 1, and I want to make it so that it's equal to 0. So add 1 to both sides. And then I can take this, and I can do the long division on that. So that's what I'm going to do next, is do, I got to look back at this long polynomial here, x to the fourth minus 7x cubed, oops, plus 13x squared plus 3x minus 18, all of that divided by that x plus 1. And when I get a solution to this, I'm one step closer, right? So let's look for solutions here. Well, I need to make x to the fourth. I need to multiply by x to make it. What times x equals x to the fourth? Well, that's x to the third, or x cubed. So I will distribute that x cubed times x to the fourth, or times x is x to the fourth, plus x cubed times 1 is x cubed. Now remember, I need to subtract there, so I'm going to change the signs. That is, I'm going to distribute a negative, and I'm going to call this minus, that looks ugly. I'm going to call the minus 7x, I'm going to call that plus, that still looks ugly, plus negative 7x cubed, so that I know what's positive and what's negative. These two cancel. They better cancel. I designed it so that they would cancel. And then negative 7x cubed plus negative x cubed is negative 8x cubed. And I want to bring down the plus 13x squared. I'm going to put a plus up here, and I'm going to start the whole game over again. Now I got to multiply by this to make this. So that's going to be negative 8x squared times x will give me negative 8x cubed. So negative 8x squared. So when I multiply that through, I'll get negative 8x cubed plus negative 8x squared times 1 is just negative 8x squared. Now I need to subtract them. I need to distribute a negative. In other words, change the signs on both of them so that I am subtracting. These two cancel. They better cancel. That's how you designed it. And then 13x squared plus a positive 8x squared is 21x squared. Put a plus up here and start this whole game over again. So we want to bring down the plus 3x, and now I need to multiply by this to make this. Well, that looks like it's just 21x, right? Because 21x times x is 21x squared. Plus 21x times 1 is 21x. Change the signs so that I am subtracting. These two cancel. Whoops, wrong color. These two cancel. They better cancel. That's how I designed it. And then 3x plus 21x, or plus negative 21x, I'm sorry, is negative 18x. And we'll bring down, let's call this plus negative 18. We'll bring down the plus negative 18. Put a plus up here, and we'll start the game over again. Now I need to multiply by this to make this. What's going to do that? Well, negative 18 is going to do that. So negative 18 times x is negative 18x, plus negative 18 times 1 is negative 18. And when I subtract those, everything cancels, which I knew was going to happen because a remainder of 0 means that if you plug in the x equals thing, you're going to get 0. Those mean the same thing. So then, now I have, let me copy this down, x cubed plus negative 8x squared plus 21x plus negative 18 as the next thing that I have to find a solution to. Well, that means going through the same process here. Find possible rational solutions. Factors of 18 are 1 and 18, 2 and 9, 3 and 6, just like they were before. Factors of 1 are just 1. So I can do plus or minus 1, plus or minus 18, plus or minus, plus or minus 2, plus or minus 9, plus or minus 3, plus or minus 6. And then I gotta test them and hope that, first I'm gonna hope that the 1s come out because the 1s are easy, okay? So let me test, I don't have to test positive 1 actually, because I tested it on the last one and it didn't work on the last one, it's not gonna work on this one. But I could test negative 1 again, okay? And so let's see what happens if let's call this g of x because it's a new function. Let's see what happens if I plug in negative 1 for this. I get negative 1 cubed, which is negative 1, plus negative 8 times positive 1, because negative 1 squared is 1, plus 21 times negative 1 is negative 21, plus negative 18. Everything's negative, so there's no possible way that'll come out to 0. So now I'm getting into some tougher territory. When you get into tougher territory like this, what you can do is you can graph it using technology. Okay, and let me graph it for you, and I'll show you what that graph looks like. And I'm going to use Desmos, the Desmos graphing calculator, to do this. And I am just going to type in exactly what I had, here. I'm just going to type in g of x equals, and then I'll have x to the third. I'll just put minus 8x squared, it's a little bit quicker, plus 21x minus 18, and then I'll look, see right here, so here it looks like 2 is going to work, and it looks like 3 is going to work, and Desmos actually tells me that it will work, because see, the y coordinates are 0, so I could use either one of those. So here's what the graph looked like when I did that. Let me copy it down here real quick. Mostly I'm going to copy down just the really important pieces of it. So here's what it looked like. Looked like this, and then like that, and then like that, kind of. With an x-intercept at x equals 2 and another x-intercept at x equals 3. So I can just take one of those. Let's say, so now I know that x equals 2 is a solution. Okay? So then I solve that so that it equals 0. So I have x minus 2 equals 0. And then I can use this to do the long division. Okay, so I will do the long division here. I'm going to have to copy this again. X cubed plus negative 8x squared plus 21x plus negative 18 divided by x minus 2. And now I'm going to do the long division again. And you keep going through this process until you get it down to squared, which is what's about to happen for us. Okay? So I need to multiply by this to make this. That is, again, the process. And that'll mean I use x squared, because x squared times x is x to the third. Let's call this plus negative 2 instead of minus 2. So plus x squared times negative 2x is negative 2x squared. Change the signs so that I am subtracting. These two cancel. And then negative 8x squared plus 2x squared is negative 6x squared. Bring down the plus 21x, put a plus, and start the game over again. Now I need to multiply this to make this. So as I wait for the other screen to catch up here. So now I need to multiply by x to make negative 6x squared. Well, that'll be negative 6x times x is negative 6x squared plus negative 6x times negative 2 is positive 12x. Change the signs so that I am subtracting. These two cancel. And then 21x plus negative 12x sounds to me like 9x, positive 9x. Let's bring down the plus negative 18, put a plus up here, and start over again. We need to make 9x. We need to multiply by x to do it. That's 9 times x makes 9x, plus 9 times negative 2 is negative 18, and when I subtract all of that, will cancel, leaving me with a remainder of 1. So now I'm down to just one final thing that I need to do, which is I need to take this quadratic that I've got at the top there, and I need to set it equal to 0 and solve it. So what I can do, let me check something here. Okay. So what I can do, let me do that work over here. I want to do x squared plus negative 6x plus 9 equals 0. And my hope is that it factors. So let me look at it as x squared minus 6x plus 9 equals 0. Because if I can get this to factor, the work's a lot easier to do, right? So I would need two things that multiply to make this, and do this to make this. Well, first, the x squared gives me x and x there. A plus here means they're both this, so it's x minus and x minus. And two things that multiply to make 9 and add to make 6 are 3 and 3. Okay, so now I've got x minus 3 times x minus 3 equals 0. Well, zero product property tells me that if I multiply two things and I get 0, at least one of them has to be 0. I don't know which one, so I count for all cases. So either that first x minus 3 equals 0, or that second x minus 3 equals 0. And then I just solve them both. If I add 3 to both sides, I get x equals 3. And if I add 3 on both sides, I get x equals 3. Now you might be saying, those are the same. Well, they certainly look the same, but the importance is that we got it twice, okay? And the reason that's important is because that gives us our 4 solutions, okay? So we've got x equals 3, x equals 3, x equals 2, and x equals -1. So our 4 zeros are x equals -1, 2, 3, and 3 again, which when you go through this lesson, you'll see that they won't write it that way, or they probably won't talk about it that way. They'll say this, and then they'll say 3 has multiplicity 2, meaning 3 happens twice. Okay? So the real solution is that one right there. Okay, so that's finding all the zeros. That's a big problem, but we got through it. So let's find all the roots, which is the zeros, the solutions for this next one, and this one's a lot smaller, right? To find all the roots for this one, first of all, how many roots are there? Well, there's only 2, so that'll be helpful. So all I have to do, since I've already got a quadratic, is just set it equal to 0 and solve it. Well, to do that, I'm going to have to subtract 26 on both sides, leaving me with 2x squared equals -26. And then I'll divide by 2 on both sides, and that will leave me with x squared equals -13, because -26 divided by 2, a negative divided by a positive is a negative, and then 26 divided by 2 is 13. And then, in order to get from x squared to x, I need to take the square root, and that means I need to take not just the square root on the other side, but the positive and negative square root. That is to say, if I told you I squared some number and got 25, I could have done 5 squared and got 25, but I also could have done parentheses in the wrong place, -5 all squared and also gotten 25. So that's where I'm getting the plus and minus from. So the square root cancels the square and leaves me with just x. And then plus or minus equals plus or minus. The square root of 13 is the same as or the square root of -13, I'm sorry, is the same as I times the square root of 13. So here are my 2 answers for this. Positive I times the square root of 13 and negative I times the square root of 13. And that is not a coincidence that we got both the positive and negative of a complex number, of a number with I in it. It turns out that always happens, and we'll talk about that a little bit more later. Let me go back to this for a second, give some time for questions. If there's a question, now would be the time. You can unmute and ask, or you can put it in the chat. Okay, there being no questions. Let's move on to another one. Find all the zeros. We got another big one here. However, we have an advantage here. And the advantage is that I've got two probable zeros spotted because they've already given me the graph. And this is the way that they do it in Edgenuity on this one. They give you the graph for this particular problem so that you have a little more to work with. So it appears that I've got one of them at x equals -3 and one of them at x equals 3. So if I do those, if I have those, then one of them would be, if you imagine solving the first one equal to 0, it would be x plus 3 equals 0, and solving the other one for 0 would give you x minus 3 equals 0. So I can do two long division problems, and as long as the remainders come out to 0 for both of them as I work through, I should be okay. Okay, so let's start with this one. We may have to come back to this board to remember that x minus 3 is our other one, but let's do the long division on x plus 3. Okay, so I've already rewritten the polynomial so I don't forget it. I'm going to change all minuses to plus negative. That helps me keep track of what's positive and what's negative. And I'm going to divide all that by x plus 3. So another long division problem. So hopefully you're seeing the long division quite a bit, and hopefully you're even starting to understand the long division. Remember, if you've got questions, put them in the chat. I will definitely answer them. So I need to make x to the 4th. That sounds like x to the 3rd times x. So x to the 3rd times x is x to the 4th, plus x to the 3rd times 3 is 3x to the 3rd. Let's change the signs so that we are subtracting. Those two cancel, and negative 4x cubed plus negative 3x cubed is negative 7x cubed. Bring down the plus negative 4x squared. Put a plus. Start the whole game over again. Now I need to make negative 7x cubed. I need to multiply by x to do it. So that sounds like negative 7x squared to me. So negative 7x squared times x is negative 7x cubed, plus negative 7x squared times 3 is negative 21x squared. I need to subtract those, so I need to distribute a negative, which means I need to change the signs down here. Those two cancel because that's how you designed it, and then negative 4x squared plus 21x squared is, let's see, that's positive 17x squared. Bring down the plus 36x, put a plus up here, and we'll start the game again. Now I need to make 17x squared. That sounds like 17x times x is 17x squared. That squared looks awful. There we go. Plus 17x times 3. 17 times 3 is 30, plus 21 is 51x. And change the signs down here so that I am subtracting. Those two cancel. That's how you designed it. And then 36x plus negative 51x. that negative 15? Yeah, negative 15x. Bring down the plus negative 45. Put a plus here, and we'll start the game over again. Now I need to make negative 15x. Well, negative 15 times x will give me negative 15x. Negative 15 times x is negative 15x, plus negative 15 times 3 is negative 45, and those cancel, so I get a remainder of 0, so that means x plus 3 works. That's nice. And I've got the new polynomial to divide by x minus 3. So let's see, that's x cubed plus negative 7x squared plus 17x plus negative 15. And now let's do the long division with the other one that we're pretty sure we know, which was x minus 3. That's because on the graph we had an x equals negative 3 and an x equals 3, looking like those were both x-intercepts. Okay? So now we need to make x cubed. X squared times x will be x cubed plus, let's make this minus 3 a plus negative 3 so we can keep track of our positives and negative easily. X squared times negative 3 is negative 3x squared. Let's change the signs so that we are subtracting. Those cancel, that's how you designed it, and then negative 7x squared plus positive 3x squared is negative 4x squared. Bring down the plus 17x, put a plus, and start over. Now I need to make negative 4x squared. I got to multiply by x to do it, so that's negative 4x times x is negative 4x squared plus negative 4x times negative 3 is positive 12x. Change the signs so that I am subtracting, distributing that negative 1. Those cancel, that's how you designed it. And then 17x plus negative 12x is 5x. Bring down the plus negative 15 plus, and start over. Now 5 times x is 5x. I hope you can see that. 5 times x is 5x. Plus 5 times negative 3 is negative 15. Those all cancel when you subtract them, giving you another remainder of 0, so that's really good. That means that x equals 3, that is a factor of x plus negative 3, or x minus 3, is also a factor, is x equals 3 is also a 0. So now we've confirmed both of those, and we've narrowed it down to just a quadratic. X squared minus 4x plus 5. X squared minus 4x plus 5. And so now I'm going to take that, I'm going to set it equal to 0, and I'm going to solve it. Now it would be great if this would factor. So let's try it. I would need x and x. If there's a plus here, they're both this. So it would be x minus and x minus. And then I would need two things that multiply to make 5 and add, add to make 4. Unfortunately, the only two things that multiply to make 5 are 5 times 1. So I can't factor it. So instead, I have to move on to the other technique, which is completing the square. So let me take you through completing the square on this. I would subtract 5 on both sides. and have the setup of x squared minus 4x equals -5. So the ability to complete the square requires you to have x squared by itself. That is, you can't have 2x squared or 3x squared, those sorts of things. And the numbers on one side of the equal sign and all the terms with x's on the other side of the equal sign. So the constants, we call them over here, and the other terms, the variable terms, over here. Then you do the side work to complete the square. You take this number and you take half of it, which in this case happens to be 2. You square that, and then you add that thing and then subtract it away again immediately. Okay? So I'm going to write that down. X squared minus 4x plus 2 squared minus 2 squared equals -5. And you do that because this part here is now your completed square. And you are able to write it as a perfect square. You take this, this, and this, and that's how you write the completed square. So we take, instead of x squared, it's x, and then this minus right here becomes a minus, and then that 2, this 2 right here, and then you put the squared up here. Now, the reason that works is because if you took this and squared it, that is, if you did x minus 2 times x minus 2 again, you'd get this thing. That thing in brackets. Okay? Then minus 2 squared, which we'll call minus 4, because 2 squared equals 4, equals -5, and then it's a problem that we can do. I can add 4 to both sides and have x minus 2 squared equals -1. Then I can square root and plus or minus the square root, and have x minus 2 equals plus or minus the square root of -1, which is just I, the imaginary number I. And then I can add 2 to both sides, and typically we write this as x equals +2 plus or minus I, like that. And that gives us all the answers that we need. So let's go back and look here. What were our first two answers? They were x equals -3 and 3. How many answers should we get? 4 answers. So -3 and 3 are 2 of the answers, and then 2 plus I and 2 minus I. So -3, 3, and then 2 plus I and 2 minus I are our 4 answers, our 4 solutions, our 4 zeros. Okay? One last thing to talk about, and this is just a rule. We call this the complex conjugate theorem. And I think you've been seeing that we've sort of looked at it twice now. I'll show you again. The complex numbers, the numbers that include an I, come in pairs. They never come individually. So here's something with an I. So if I tell you that a polynomial has a root of -5 plus the square root of 3i, then another root has to be, by the complex conjugate theorem, has to be the other pairing, which is -5 minus the square root of 3i. So those always come in pairs. The I things always come in a plus bi and then a minus bi also. The fact that there's a square root right here doesn't matter. All that matters is that there's an I. Okay? Same thing up here. All that matters is the fact that there's this I right there. All right. So that is 6.3, or 6.4. I'm sorry, 6.4, the fundamental theorem of algebra. Thank you.